Question 1. In a class of 30 students, 18 are fluent in Spanish, 10 are fluent in French, and 5 are not fluent in either of these languages. The following Venn diagram shows the events fluent in Spanish and fluent in French. The values M, N, P, and Q represent numbers of students. Write down the value of Q. Well, Q represents the value for those that aren't fluent in either Spanish or French. So that is 5. So Q is equal to 5. To find the value N, we need to find who are fluent in both French and Spanish. We know 18 are fluent in Spanish and 10 are fluent in French. So M is equal to 18 minus N. P is equal to 10 minus N. And N is fluent in both. Well, we know that they add up to 25, 30 minus 5. So therefore, we can write the equation 18 minus N plus 10 minus N plus N is equal to 25. Those two cancel. So we're left with 28 minus N is equal to 25. So N is equal to 3. Now we know that N is equal to 3. We've already discussed that M is equal to 18 minus N and P is equal to 10 minus N. Therefore, M is equal to 18 minus 3, which is 15. P is equal to 10 minus 3, which is equal to 7. We're told that f of x is equal to x plus 3 over 4 and g of x is 8x plus 5. Show that g of f of x is 2x plus 11. We do f of x first, followed by g of x. So we substitute f of x into g of x. So therefore we get g of f of x is equal to 8 lots of x plus 3 over 4 plus 5. Let's do some cancelling. So we get 2 lots of x plus 3 plus 5. Multiply out your bracket, you get 2x plus 6 plus 5, which is equal to 2x plus 11. In this question, given that the inverse of g of f is equal to 4, find the input. That just means that we can put 4 into g of f of x, which we know is 2x plus 11. So we work out g of f of 4 which is equal to 2 times 4 plus 11, which is equal to 19. In equation 3, we're told that g of x is equal to x squared plus bx plus 11. We're also told that the point minus 1/8 lies on the line, and we're asked to find the value of b. Substitute x is minus 1 into the equation, and the output will be 8. So therefore we get 8 is equal to minus 1 all squared plus b lots of minus 1 plus 11. So 8 equals 1 minus b plus 11. Therefore b is equal to 4. In part B, we're told that the graph f of x equals x squared is transformed. To make the graph g of x, we have to describe the transformation. So that means that x squared goes to x squared plus 4x plus 11. In order to describe the transformation, we need to complete the square for x squared plus 4x plus 11. So there we go. Halve b, so we get x plus 2 all squared. Subtract b squared plus 11. So we get x plus 2 all squared plus 7. That means there has been a translation by the vector -2, 7, or 2 spaces to the left, 7 spaces up. Question 4. Solve the equation 2 log x equals log 9 plus 4. Give your answer in the form x equals p e to the power of q. P and q are positive real numbers. So 2 log x is equal to log x squared. So therefore we've got log x squared minus log 9 is equal to 4. Use the subtraction rule, which means log x squared over 9 is equal to 4. Now raise to the power of e, so you get e to the log x squared over 9 is equal to e to the power of 4. These cancel each other out, so we get x squared over 9 is equal to e to the power of 4. Therefore, x squared is equal to 9e to the power of 4. Therefore, if we square root both sides, we get the square root of x squared equals the square root of 9e to the power of 4. Therefore, x is equal to 3e squared. P equals 3, Q equals 2. Question 5. In an arithmetic sequence, U2 is equal to 5, U3 is equal to 11. Find the common difference. We know that any term in an arithmetic sequence can be written as UN equals U1 plus N minus 1 D. Therefore, U2, which is equal to 5, is equal to U1 plus D, and U3, which is equal to 11, is equal to U1 plus 2D. If I subtract one from the other, I get 11 minus 5 is 6. U1's cancel, I get D. So D is equal to 6. 5b, find the first term. Well, I know that the first term, U1, is equal to the second term, U2, minus D. So U1 is equal to 5 minus 6, so U1 is equal to minus 1. 5c, find the sum of the first 20 terms. So using the summation formula, which is s to the n equals n over 2 2u1 plus n minus 1 d, where n is 20, so therefore s20 is equal to 20 over 2, 2 times minus 1, plus 20 minus 1, which is 19, times 6, which is equal to, when you sum them all up, 1,120. In question 6, we're told 11 choose A is equal to 11 factorial over A factorial 9 factorial. And we're asked to find the value of A. Use the combinations formula, which is n choose R is equal to n factorial over R factorial n minus R factorial. And we're given 11 choose A is equal to 11 factorial over A factorial 9 factorial. That means that 11 minus R is equal to 9. So R must be equal to 2. Therefore, A is equal to 2. In any binomial expansion, each term can be written as n choose R, A to the n minus R, B to the R. In our case, n is equal to 11, A is equal to x, B is equal to 3, and R is unknown. So therefore, we have 11 choose R, x to the 11 minus R, 3 to the power of R. And we know that that is equal to some coefficient x to the power of 9. Well, 11 minus R, must equal 9. Therefore, R is equal to 2. Therefore, we've got 11 choose 2, x to the power of 9, 3 to the power of 2 equals some coefficient x to the power of 9. Well, that coefficient is 11 choose 2, 3 squared. Well, we already know what 11 choose 2 is. We can work it out. It is 11 factorial over 2 factorial 9 factorial, which is equal to 11 times 10 times 9 times 8 all the way down to 1 all over 2 times 1 times 9 times 8 times 7 all the way down to 1, which is equal to 11 times 10 over 2, because that cancels with that, which is equal to 55, and then we multiply it by 9, which is equal to 495. Question 7. A group of 10 girls recorded the number of hours they spent watching television during a particular week. Their results are summarized in a box and which are plotted below. 7a. The range of the data is 16. Find the value of A. Well, the range is the largest value, A, subtract the lowest value, which is 8, and we know that that is equal to 16. So we can write A minus 8 equals 16. So A is 16 plus 8, so A is 24. 7b, find the value of the interquartile range. Well, the interquartile range is equal to Q3 minus Q1. In this case, Q3 is 20, the largest value in the box plot, minus 15, which is the lowest value in the box plot. So the interquartile range is equal to 5. You're told that the group of girls watched a total of 180 hours of television. Find the mean number of hours that the girls in the group spend watching television this week. Well, the mean is the sum of all the x values divided by how many there are, which in this case is 180 divided by 10, which is 18. So the mean number of hours is 18. You are then told a group of 20 boys also recorded the number of hours they spent watching television that same week. Their results are summarised in the table below. The mean number of hours x bar is 21 and the standard deviation is 3. Find the total number of hours the boys spent watching television this week. Well, we can use the mean for this. So the mean is the sum of x over n. Well, we know that that is equal to 21. So therefore, if we substitute the rest in, we know that the sum, the number of boys is 20. Therefore, the total number of hours is equal to 20 times 21, which is 420 hours. 7e, find the mean number of hours that all 30 boys and girls spent watching television. Again, use the formula for mean. So it's the total number of hours over the number, which in this case is 180 plus 420 divided by 20 plus 10, which is 600 divided by 30, which equals 20 divided by 30 is 20. The following week, the group of boys had exams. During this exam week, the boys spent half as much time watching television compared to the previous week. For this exam week, find the mean number of hours that the boys spent watching television. Well, that's easy. It is a half times 21, which is 10.5 hours. The following diagram shows part of the graph of f of x, which is equal to k over x, for any value of x greater than 0 and any value of k greater than 0. P, the point pk over p, is any point on the graph, and the line L1 is the tangent to the graph at the point P. 8a, find f dash of p in terms of k and p. We need to differentiate f of x. We know that f of x is equal to k over x, which is equal to k x to the power of minus 1. Now if we differentiate and get f dash x, multiply by the power, so we get minus 1, kx, take 1 off the power, minus 2. Bring the power back down to the bottom, we get f dash of x is equal to minus k over x squared. Therefore, f dash p is equal to minus k over p squared. 8b, show that the equation of the line L1 is equal to kx plus p squared y minus 2pk equals 0. So we're going to use the equation of the line y minus y1 is equal to mx minus x1. Therefore, we know that y minus k over p is equal to minus k over p squared x minus p. Multiply out the bracket, so therefore we get y minus k over p is equal to minus kx over p squared plus k over p squared. Therefore, we get y is equal to minus kx over p squared plus 2k over p. I'm going to multiply every term by p squared, so therefore we get yp squared equals minus kx plus 2kp. Take everything to the left-hand side, we get yp squared plus kx minus 2kp is equal to 0. 8c. The line L1 intersects the x-axis at the point A is equal to 2p0 and the y-axis at the point B. Find the area of the triangle AOB in terms of k. Well, if we draw our triangle, we will get, there's our right-angled triangle. We know that this is the point 2p0. We know that this is the point 0, 0, and we have to find the point B. Well, we know that the x-coordinate at B is 0. So, if we put 0 into our equation for L1, we get k lots of 0 plus p squared y minus 2pk is equal to 0. Therefore, p squared y is equal to 2pk. So y is equal to 2pk over p squared, which is equal to 2k over p. Therefore, we know the width of our triangle is 2p. We know the height of our triangle is 2k over p. So we can find the area. So the area is equal to a half times 2k over p times 2p. Well, that cancels with that. That cancels with that. So the area of our triangle is equal to 2k. 8d. The graph of f is translated by the vector 4, 3 to give the graph of g. In the following diagram, point Q lies on the graph of G. Points C, D, and E lie on the vertical asymptote of G. Points D and F lie on the horizontal asymptote of G. Point G lies on the x-axis such that FG is parallel to DC. The line L2 is the tangent to the graph of G at Q and passes through E and F. Given that the triangle EDF and rectangle CDFG have equal areas, find the gradient of L2 in terms of P. Let's take a look at the triangle EDF. This now has the points D, which is at 4, 3, F, which has the coordinates 2p plus 4, 3, and E, which has the coordinates 4, 2k over p plus 3. Therefore, finding the gradient of the line, L2, we get 3 minus 2k over p plus 3 all over 2p plus 4 minus 4, which is equal to minus 2k over p all over 2p, which is equal to minus 2k over p times 1 over 2p, which is equal to minus 2k over 2p squared, which is equal to minus k over p squared. If we now look at the rectangle CDFG, we get CDFG looks like this. Well, we know that the coordinates at that point are 4, 0. We know that the coordinates at that point are 2p plus 4, 0. We know the coordinates at this point are 2p plus 4, 3. And we know the coordinates at this point are 4, 3. That makes DC equal to 3, and it makes CG equal to 2p. Therefore, the area DC times CG is equal to 6p. But we know that that area is equal to the area of the triangle. Therefore, 2k is equal to 6p. Therefore, k is equal to 3p. We now have a value for k that we can substitute into minus k over p squared. So therefore we get minus 3p over p squared, which is equal to minus 3 over p. So the gradient of L2 is equal to minus 3p to the power of minus 1. Let f of x equal 1/3 x cubed plus x squared minus 15x plus 17. 9a, find f dash of x. So f dash of x is equal to 3 times 1/3 x squared plus 2 times x minus 15. The graph of f has horizontal tangents at the points where x equals a and x equals b. A is less than b. 9b, find the values of a and the value of b. For horizontal tangents, the gradient is equal to 0. So we know that x squared plus 2x minus 15 is equal to 0. Factorize x minus 3, x plus 5 is equal to 0. So x is 3 or x is minus 5. Therefore, a is equal to minus 5 and b is equal to 3. 9c, sketch the graph of y equals f of x. Well, we know that the roots are minus 5 and 3, and we know that c is equal to minus 15. So our graph would look something like this. Three minus 5 minus 15. 9d, hence explain why the graph of f has a local maximum at x equal a. If you look at the graph for f dash x, at a, which is x equals minus 5, the derivative changes from positive to 0 to negative. Positive, 0, negative. Therefore, maximum. 9e, find the second derivative at b. So the second derivative, f double dash x, is equal to 2x plus 2. So f double dash 3 is equal to 2 times 3 plus 2, which is 8. 9f. Hence, use your answer to part D1 to show that the graph of f has a local minimum point at x equal a. Well, the f double dash of b is equal to 8, which is positive. Therefore, minimum. Nine G. The normal to the graph of f at the point x equals a and the tangent to the graph of f at x equals b intersect at the point PQ. Find the values of P and Q. Firstly, let's draw the cubic and see what we've got. So we have a cubic that looks like this. This is the point x equals 5, and we have a tangent here. This is the point x equals 3, and we have another tangent here. We're told that the normal at point A, which is here, and this tangent meet at the point PQ. Well, we know what the equation of the normal is. It's the line x equals minus 5. So this is the line x equals minus 5. Therefore, P is equal to minus 5. Now we have to find Q. Well, we know that this is the point x equals 3. So we need to find f of 3. So f3 is equal to 1/3 3 cubed plus 3 squared minus 15 lots of 3 plus 17. And when you work it out, that is equal to negative 10. That means that Q is equal to minus 10. Therefore, the point PQ is the point minus 5 minus 10.